Okay, this will be part 5 of the section 4.2 assignment. Starting at number 36 here, it says, sketch a graph of a differentiable function that has the given properties. So we have to make sure that we make something that's differentiable, which means differentiable at all values. Okay, so the couple of things we know for sure is that I cannot draw a straight line. Okay. F of 2 is 3. And the derivative at 2 is 0. So that tells us that we either have a situation where we have a minimum or we have a maximum, but we know that we have a slope of 0. It is possible, I suppose it could be a combination of this, where we increase slope of 0 and then we continue to increase, or we're decreasing slope of 0 and then we continue to decrease. But we know it has to be one of those scenarios. Alright, then they tell us that the derivative is greater than 0, so the slopes are positive for x is less than 2. So for x is less than 2, so that'd be everything over here, my slopes are positive. So that means I'm going up to this point. And then it says my slopes are less than 0 for values greater than 2. So that means my slopes are negative. So it would seem that for part A, I simply have a scenario where my graph is going to look something like this. There's other variations you could do, but essentially this would be the basic, easiest way of doing it. Okay, so then let's look at what part C says. I'll leave you to do the other two parts. So again, same information given. We have the point 2, 3. And again, my slope is going to be 0 there, so we'll have a horizontal tangent line. But this time it says my derivative is less than 0, so my derivative is negative for all values except for 2, where we already know it's a slope of 0. So this tells me my slopes are negative, they're negative, they're negative until here, and then right afterward they're going to have to be negative again, which means I need to keep going down. So we have some graph where again we level off here and then we curve back down. And that's how I would do 36C. So I'll leave the other two for you to do. 37 is a similar question. So let's take a look at this one. Alright, it says the derivative at -1 is the same as the derivative at 1, which is 0. So again, we have horizontal tangent lines at 1 and -1. At least right now, we don't know the y values to go with it. So I may just be making up my own value. So let's see what else it tells me. It tells me more information about the slope. More slope, more slope. So at no point in this problem does it seem to be giving me a y value. So what that means is I can make up my own. Alright, so let's just start this and maybe we'll have to erase something and change it. At -1 and +1, I know I have a slope of 0. So I'm gonna pick a point right up here. Alright. It says from -1 to +1 on this interval, my slopes are positive. So that means from wherever I am at -1, I have to have positive slopes to get up to where I am at 1. So it seems logical to me then that the point at -1 should be lower than the point at +1. And now to connect them and have again 0 slope at these 2 points, looks like that would satisfy this statement and this statement. The derivative is less than 0, so the derivative is negative for the x is less than -1. So that means my slopes are decreasing, so that means I'm coming down to this point. Again, horizontal tangent line right there. And then it says my slopes are positive for x is greater than 1. So instead of curving back down, which would be a slope of negative, looks like I'm going to continue to go up from here, making that not a local min or max, just a point. And I think that satisfies all the conditions. Okay, and let's now do number 43. You might want to pause and read 43 at this point if you haven't already done so. Okay, so on the moon, it says the acceleration due to gravity is 1.6 meters per second squared. So what they're telling me is a constant 1.6 meters per second squared. So that is the equation for acceleration. And we remember that the way I look at this is there are 3 levels, and I have found that the bottom level is the equation 1.6. Alright, if a rock is dropped into a crevice, how fast will it be going just before it hits the bottom 30 seconds later? So, how fast is a question about velocity. So I know that I need to move up a level to get to velocity. In other words, I need to take the antiderivative. So the antiderivative of 1.6 would simply be 1.6t plus a constant of some kind. Alright, so now if we look at the question, it says if a rock is dropped into a crevice, how fast will it be going in 30 seconds. So essentially, I'm going to need to plug in 30 seconds and then I'll get my answer. But first I have to deal with this plus c. And the plus c is simply the value. Notice if I plugged in times 0, then this would go away and I'd be left with velocity at 0 equals c. In other words, what we have here is the initial velocity of plus c. We could just do this completely algebraically, and let's take a look at what it says. It says it's dropped into a crevice. So in order to answer any question about solving for a c, I have to know something about my velocity at a certain time. And so since they tell me it's dropped, I know that my velocity at 0 is 0. Because when I first let go, there's no velocity. I didn't throw it down, I just let go. So now with this information of x is 0 or t is 0 and velocity is 0, I can solve for c. And so when I do that, kind of making a mess here, apologize. My velocity is 0, 1.6 times 0 plus c. In other words, for this problem, c equals 0. So that means my velocity equation can be simplified, and again I'm just completely making a mess of this. I get a velocity of 1.6 t. They want me to plug in 30 to find out how fast I'm going right before I hit the bottom, because apparently it takes 30 seconds to get down. So I do 1.6 times 30, and I get an answer of 48 units are meters per second. So there's the answer to part B, or part A. Part B says how far below the point of release is the bottom. So again, this is a question about where, which sounds to me like position. So again, if I go to my levels, I know at the bottom we had my acceleration is 1.6. We found my velocity to be 1.6 t, and we figured out the c was 0, which now means my position is the antiderivative of velocity. So that means it's going to be t squared, and I'm going to bring the 2 down when I take the derivative, and when I do that I have to create a 1.6. So it sounds like we need a 0.8 in front. Test your derivative. 2 comes down, 2 times 0.8 is 1.6, and we've got it other than a plus c. So here's my position equation. But again, I need to solve for c. So in order to do that, I have to know one relationship between time and position. And they told me that, again, I'm dropping it into the crevice, so assuming I'm basically standing at ground level and letting go. So I think what they're telling me is s of 0 equals 0. My position at time 0 is 0. I'm at the top of the crevice. So if I plug in 0 for t and 0 for position, I get c equals 0. So it looks, again, much like the last one. My position equation is now just 0.8 t squared. And I want to know where I'm at when I hit the bottom, and they told me I'm going to hit the bottom about 30 seconds later. So once again with my calculator, 30 squared times 0.8, and I get an answer of 720 meters. All right. So then let's go take a look at part C. The setup here is a little different. Now it says instead of just letting go, I'm going to give it a little bit of a throw, a little toss downward. So what that means is if we back up and we look at our acceleration again of 1.6, the velocity becomes 1.6 t plus c, but this time I have the information that velocity at time 0 is actually going to be -4. We got to be careful on those. It says with a downward velocity, and down is, you know, understood to be a negative direction. So it's a negative velocity, it's going down. So now when I plug in for time 0 and solve, we're just kind of working this problem up. So v of 0, actually let me try that again. So the velocity is negative. We did that again. Don't know how I did that. All right. Okay, back to the problem. So the velocity is -4, and we're going to plug in time 0 and solve for c, which clearly lets me know that c equals -4. So that means my velocity equation, and I've just really made a mess of this, so let's just write it over here. My velocity equation has now become 1.6 t minus 4. Now it wants to know when will it hit the bottom and how fast will it be going when it does. Okay, so what do we know? We know stuff about velocity. So we want to know how fast when I hit the bottom. But I can't use the 30 seconds from before because that was when I just let go. If I throw it down, obviously I'm going to reach the bottom a little bit faster. So what this means is I need to figure out what's a constant in this problem. And the depth of the crevice that we found back in part B of 720 would be a constant. So that doesn't change just because we're throwing it. So what does change is now I need to know what my new position equation is. So I need to find the antiderivative again. I get the antiderivative of 0.6t is 0.8 t squared, and the derivative now of -4 becomes -4t plus c. I haven't changed that I'm starting at a position of 0. So once again, if I plug in a time 0 and a position of 0, I see that c is 0. So my position equation should be 0.8 t squared minus 4t. And now I want to know how long is it going to take to reach 720. And again, that's going to be -720 because I want to reach the position that's down at the bottom of the crevice. So solving this quadratic, 0.8 t squared minus 4t minus 720, and now I need to solve for my time. Let's see here. This doesn't seem like it'd be a lot of fun to factor, so I'm going to very quickly do it on my calculator. 0.8 x squared minus 4x minus 720. I'm going to change my window to go up to a maximum of x of 30 because I know it took 30 seconds before, so it should be less than 30 this time. I'm going to graph, and I've done something wrong because I don't see it ever hitting 0, and that's not going to be the case. So let's see here. I wonder if they want that to be a positive 720. We're at 15 minutes already on this video. Okay, so let's take another 30 seconds and think about this. When is my position negative 720? Let's see here. My position equation before was set up and I found a positive 720. Oh, you know what sucks? Is from the very, very beginning, I should have done something different. And unfortunately, that means I'm going to have to redo this problem. Notice at the beginning, the acceleration was listed as 1.6, but the acceleration in this case should have been negative 1.6. And I'm sure had we been in class, somebody would have let me know this ahead of time. So I'm going to stop here, and looks like we got one more video to go. Or you know what? I'm just going to let you do all this work again, and just make sure you start with a negative as an acceleration, which is going to change some of the values here, but it should ultimately work out just fine.